Okay, so this is tutorial 2 and we're going to resolve this thing together with all of you. So this is a lift truck. Mass, definitely, there will be written there 70 kg. Then there will be the gravity point. So be careful over here because it says 70 kg at G. So where is the G? If you look at the diagram, so this is the G. So if you look at the diagram, so some people may start to misunderstand because they will see that, oh, G must be the center, so they will mistook this as the G. But look carefully, the G basically is here. So this G is the center of the whole lift truck. And the C, it is the center of this circle or spool. So some of the tricky things is over here. And 70 kg will be the whole lift truck. This whole lift truck. So will be 70 kg. And the 120 kg, the spool, that will be this thing. Okay, so we shouldn't misunderstand from here. So that's how we should look at the question. And right now, the acceleration will be 3 meters per second square. So now determine the reaction on each of the 4 wheels. Now there's another tricky part is here. 4 wheels. Because if you look at the diagram, 4 wheels may be not so obvious, but actually A have 2 wheels, B also have 2 wheels, so altogether it is 4 wheels. Okay, so that will be some of the things we need to be careful and take a look at that. And then what we need to determine is the reaction of this 4 wheel. And the loading is symmetric, so which means that it doesn't have any imbalance. So 4 of the wheel, the reaction are not say 4 of the wheel reaction are the same, because definitely reaction at A and reaction at B is different. But it doesn't. It means over here it is at A, the 2 wheel. Basically, the reaction are the same. If you look at the top wheel for A, 2 wheel over here. So the reaction basically here and here are the same. That same happened to B as well. Okay, so neglect the mass of the movable arm CD. So there is the arm that talking about the CD is this arm. Because we know that this is C and that will be D. Look carefully for the diagram. Okay, so that is how we can digest our question. And as usual, if question like this is asking for the reaction on the wheel, so free body diagram is something that we cannot neglect. So where can we start over here? I will start drawing my free body diagram. So I will draft it. Roughly that will be my lift truck A and B. So I will label that each of it. A, B, the D, and the C. And one important point that people always neglect is the G. So our free body diagram, definitely they will work in this manner. So I have gravity point, but that is for my spool. And I have another gravity point, that M is my lift track. So I put lift times G. Okay. Then reaction at A, so I put at A. Reaction at B. Take notes. There will be 2A and 2 for B. And that will be the free body diagram. And right now, there's another diagram which is the kinetic diagram, we all know. So that will be the right hand side. And this denotes the motion of the lift truck. If you look at the question again, the question is saying that the spool, it is lifted up 3 meters per second square acceleration. So if the spool is moving up, so which means the direction must be the center point of the spool, and that it is C. And there will be my mass for the spool times not gravity, because it's lifting up, there's the motion, so there is A Y, because it is on the Y direction. And if I put my kinetic diagram side by side with my free body diagram, so my free body diagram and my kinetic diagram equal, so as we know, they will be equal, and that will be the complete for the equation of motion in dynamic. So after we plot the diagrams, right now you are supposed experience enough, because we have resolved a few questions in the class. We should experience enough, know that we're going to start with moment, because normally to unlock question like that, moment give me the first answer of the reaction. Summation of the fx or fy, normally I will stuck. Then I'm going to resolve. But yet it is true, you write all the mathematical expression, summation fx, summation fy, summation moment, pin on the point that you prefer. Then we talk about next step, how to resolve it. But right now we should know that moment normally is the one to give us the answer first. So I will going to resolve moment right now, rather than to write the mathematical expression first. So, but if you look at that, definitely we have moment, and we also have summation fy only. Because you look at the diagram, there is no force or motion on the x direction. You see, there will be only y, up and down. So that will make our life much more easy. So why not we choose a point first, and you can choose any point because you take a look at the diagram. So A, B, C, G or D, that actually all these points, they only have one force. So if we pin on whatever force it is, any point of it, that actually doesn't help us, so-called we eliminate more force or more unknown. But I will still choose either A or B, because A or B can eliminate some of the point or some of the force over there. So let's say I will choose B. So my summation M I will pin at B, so equals to the, because it's not G again, look at the diagram on the look at the kinetic diagram. So if you want to eliminate this force, you choose the point at C. Okay, you choose a point at C, because the truck doesn't move, so that's why there's nothing actually on G is moving, so it's C, the spool is moving. So if you want to eliminate this, of course you can pin at C, so that this will be eliminated, then that will be equal to 0 over here if pin at C. But right now this doesn't happen to rest, because I say I want to pin at B, but there is just some clarification. So I will put unknown, still moment, but there I will say that the summation of moment and the kinetic diagram, and then that will pin at B point. So that should make some clarification over here. And don't forget, declare the direction of your moment, which is positive, which is negative. I always like anti-clockwise as positive, because we need the distance. So I refer back to this diagram. There's my free body diagram. Okay, so 2 and A, then with 2 and B, then the M spool times G, M, that's my lift truck, times G. So if I pin at B, definitely B, all the force at that point will be out of the picture. I pin here. So now we can start to do a calculation for that. For my first moment, I will choose this. And the distance towards B will be 0.5. That will be my moment 1. M 70, G is the gravity, acceleration times the distance 0.5. Okay, so the second I'm going to choose will be my spool. But that will be the distance 0.7, because it is from that force acting point towards the B point distance. And then the last, of course, will be my 2 and A, and the distance towards B. And the distance will be 0.75 plus 0.5. That will give us 1.25. So if you are not writing everything up, you want to label diagram, so you can always write it over here. For example, M1, I will going to write as 79.81, because 70 is the kg, 9.81 is the g, times the distance. Just now we see 0.5. and look at that carefully. If you're still not able to identify the rotation direction of the moment, so I always encourage you to do something like that. So your force and the distance, that is B, so that will be my force of my M lift G. If I pin it here, so definitely that will give me some rotation in such direction. So that will be anti-clockwise. So if it's anti-clockwise, then okay, no problem, positive. I can also write my calculation for my M2. So the spool it is 120 and then 9.81, and the distance will be 0.7. And then same, if you look at the diagram, that will give me also the force is here and the pinpoint is here, B. So that definitely now you can visualize that thing basically that will go in that direction. Okay, so roughly the animation is like that. So because of that, I will give that also is positive. Remember that I declare anti-clockwise is positive. And the last of my M3, I will write that. So I move the unknown a bit. I will write the equation that will be 2A to an A times the distance. So 0.75 plus 0.5, that will be 1.25. And the force it is up and the B is here. So definitely the rotation that will be on that. And this will be clockwise. Okay. So and because of that, that will give me negative there. So if I put all of them together, M1 plus M2 plus M3 will be my free body diagram moment on my left hand side. So all this together, M1, M2 and M3. And on the right hand side, which is the summation of moment kinetic diagram. So over here, that will be 120 times AY. AY is the acceleration moving up. The question already given that it is 3. And the distance of the CD, C to D, actually is C to B, same. So will be 0.7. And if you look at this force, pin at B, so you can roughly imagine how the direction of course is moving towards clockwise. Okay, if it is clockwise, then that will be negative. So if we take a look at the whole things, M1, M2 and M3, just know what we have right. They will be arranged in such manner. Positive, positive, then that will be negative. So if you look at this mathematical expression, we only have one unknown. That is NA. So very obvious, we can get our NA using calculator. Roughly you will get 567.7 Newton. So after we got our NA, now we can resolve our NB by writing summation of Fy equal to MAY. So one is the free body diagram, another one there will be kinetic diagram. So over here it's become very simple because look at the free body diagram. I will have my 2 NA plus 2 NB minus my M spool G minus my M with G equal to my M. Definitely this M is the spool Y because it's going up, so that will be positive. And we just got our answer for the NA, so that will be 567.7, and all these you guys definitely know it. And that as well. So this mathematical expression, again, simple, because we only have one unknown left, which is NB. So you can see that here 2 NA, so 2 times 567.7, so 120 times 9.81 minus 70 times 9.81 equals to 120 times 3. By resolving that, our NB will be equals to 544 and A. So right now we resolve this question. NB and our NA.